Okay, so we're continuing to work with Pythagorean theorem. The other layer we're going to add to this, we're going to call this the converse of the Pythagorean theorem. This relates back to something we studied earlier this year when we figured out if we looked at three sides or three segment lengths, we could decide whether or not we could have a triangle in the first place. If you remember, we'd always look at the two smaller sides, where we just simply add them together. If the two smaller sides added up to be bigger than that third side, then we knew we at least could make a triangle. If they weren't at least that long in their sum, compared to the third side, it'd be impossible to make a triangle. So we know with the Pythagorean theorem, what's unique about a right triangle is that this relationship always holds up. If this is a right triangle, throw my little right angle in there, then we know when we take c squared, it's going to be equal to a squared plus b squared. So I want you to look at that picture and think about what would happen if a and b moved closer together. What if I made c smaller? Well, if I made c smaller, okay, and I don't change a or b, well, then this isn't going to be an equal sign anymore. What's going to happen to this sign? If c gets smaller, then c is going to be less than a squared plus b squared. And you can picture as this gets smaller, that's no longer a 90-degree angle. It's going to be an acute angle. So therefore, we'd have an acute triangle. Likewise, let's suppose c gets bigger. Well, if we don't change a squared or b squared, but we make c bigger, then c squared is going to be bigger than the sum of those two. And this 90-degree angle is going to have to get larger than 90, and we'd have an obtuse triangle. So that's what we're thinking about today. In the first example here, this is exactly what we want to do. We're going to have all three sides. And I want you to be able to tell me, first of all, just as a review, is there a triangle at all? So there may be somewhere there's no triangle that's possible. And then whether if it is a triangle, is it a right triangle? Is it an acute triangle or is it obtuse? Okay. So look what we have here. We take one side, 10, and we square it. That's 100. Okay. Then we take the other side, 10 root 3, and we square that. That's 300. Then we take this third side, the hypotenuse, if it's the largest side, square that and it's 400, and we notice that the two smaller sides squared sum to equal the third side squared, so this would indeed have to be a right triangle. Okay, and that's all we're going to do. We're going to test and see which type of triangle it is, if we even have a triangle. So in our first example here, we have 30. We're going to square that. I'm going to take 40 and square that. And then over here, I'm going to have 50. And I'm going to just try to figure out what an equality symbol would have to live in between those two. Is it an equal sign, less than, or greater than? By the way, let me just reiterate, if I take 30 plus 40, that's 70. That's definitely bigger than 50, so we know at least we have a triangle to begin with here. So here I have 900 plus 1600, and then I'm going to compare that to 2500. And what do we notice? When I add these two together, indeed I get 2500. So I can go ahead now and tuck in my equal sign, and then I write my conclusion. What I have here is a right triangle. Okay. Let's try the same thing with the next one. I have 20. I want to square that. So I take 20 squared. We just did 30 squared. We know that that's 900. And we also just did 40 squared. We know that that's 1600. So I want to put an inequality symbol here. So I have 400 plus 900. And then over here I have 1600. So what's happened here? 1600 is going to be greater than this 1300. These two sides here, 1600 is greater than that. So what kind of triangle is that? That's an obtuse triangle. When that third side is longer than what the hypotenuse would be, then that means the 90-degree angle must be larger than 90. So that's an obtuse triangle. Okay, so first, again, I'll check 18 plus 24, 42. Much bigger than 30, so we're safe to attempt this one. 18 squared, 24 squared, and we've done 30 squared. Again, third time here, we know what that is. So for 18 squared, I get 324. For 24 squared, I get 576. And then for 30 squared, I have 900. So I'm going to add these two together. So 324 plus 576 is also 900. So what we have here now is a right triangle. This follows the Pythagorean theorem. Okay, so a little bit smaller, easier numbers to work with now. We've got 6, I square that, plus 8, and then we're going to compare that to 9 squared. So I have 36 plus 64, and then over here I have an 81. So this is 100 when I add these two together. That's certainly bigger than 81. So what kind of triangle do we have now? If those two smaller sides can be bigger than that third side, it's acute. It's not, that third side's not big enough to make a right triangle, so we'd have an acute triangle. Okay. Okay, so number 5, again, let's do our check to start. 6 plus 12, is that bigger than 18? Actually, it's not, right? 6 plus 12 equals 18. That's going to be a problem. This is no triangle at all. Remember, that has to equal bigger than 18. It can be 18.0001, but it has to be bigger than it, okay? So this would give us no triangle. We don't bother with that one. Okay, so 10 plus 15, 25. We're going to be good there. We take 10 squared plus 15 squared, and we're going to compare that to 20 squared. So 10 squared is 100. 15 squared is 225. That's going to add to 325. We've squared 20 several times today. That's 400. So what we find here is that this side is bigger than what we'd expect with Pythagorean theorems. When that hypotenuse gets bigger than a 90-degree angle, this would be an obtuse triangle. Okay, I want to give you a couple of these to practice on your own, but I don't want you to panic when you see these radicals. Actually, what you should realize is that they're very, very easy to work with. So I'm still going to take root 5 and root 12. They're the two smaller sides. So we would look at what's root 5 squared, what's root 12 squared, okay, and what's root 13 squared. Well, believe it or not, it's really easy. Root 5 squared is 5. That square and the radical, they just cancel each other out. It's going to go away. So I have 5 plus 12, and I'm going to compare that to 13. Okay? So if I add 5 and 12, I get 17. That's bigger than 13. So that this side that normally in a right triangle would be equal to it is now smaller than that. That's an acute triangle. Okay? So I want you to try 8 and 9 on your own. I want you to try 8 and 9 on your own. Compare the two smaller sides squared to that sum, and let's see what you get. Okay, so let's see what happens with number 8. I'm going to take 2 squared. I'm going to add that to root 8 squared. And we're going to compare that to root 12 squared. Okay, so 2 squared is 4. We just showed you how easy it is to square the root 8. It's just 8. And then same thing with root 12. That's just 12. So what do we find here? 12 equals 12. So hopefully you classified this as a right triangle. Okay, so you need your calculator handy for this one. We've got a couple big numbers coming our way. 9 squared, not a big deal. We can do that one. 40 squared, maybe you can do that in your head. Check it on your calculator. And then what do we have? We have 41 squared. Don't have that one memorized probably. So 9 squared is 81. 40 squared is 1600. And then what we find when we square 41, we get 1681. So if I add these two together, what do I get? I get 1681. And that obviously equals 1681 over here. So we finished our assignment here with two right triangles.